Why is it said that experiencing death on other planets is an incredibly thrilling sensation? Imagine stepping into the abyss of Jupiter, where you would be instantly torn to shreds by monstrous storms. Under the scorching heat of Venus, you would be incinerated to ash in seconds. On the wastelands of Mars, you would suffocate from lack of oxygen, gradually losing consciousness. In the frigid storms of Neptune, a few seconds is all it takes to turn you into ice crystals. Such deaths are anything but ordinary. Next, let me take you on a journey through the 8 planets of our solar system to experience those extreme and fatal planetary tours you've never encountered before and to feel the deadly challenges they present. We begin with Mercury. Standing on the sunlit side of Mercury, you would immediately feel an inescapable heat wave. The temperature soars to 427 degrees Celsius, hot enough to melt lead. With no atmosphere to block it, the sun's radiation directly assaults the surface, giving you a nearly fatal dose of exposure. There is no air to breathe, and heat cannot be transferred as it is on Earth. Your skin would be instantly burned by the ultraviolet rays, followed by a pain so intense it could drive you to madness. Then, your skin would begin to blister, and the moisture from your eyes, tongue, and even your skin would rapidly evaporate. It's like being exposed to a vacuum. No air, nothing to mitigate the extreme heat. Your shadow would be sharp on the ground, yet the sky would remain pitch black because there is no air to scatter the sunlight. You would have almost no time to adapt, as the high temperature and lack of oxygen would quickly overwhelm you. Within seconds, the insulation of your spacesuit would fail against the heat wave, and the cooling system would shut down. All around you are gray rocks and craters, baked scorching hot under the sun, looking like a burning furnace. Although Mercury's gravity is only 38% of Earth's, making you feel light, the unbearable heat would make you feel almost too heavy to move. Within seconds, breathing would become incredibly difficult, and your vision would start to blur. You can't even gasp for breath because there is absolutely no air. Your brain would begin to suffer from oxygen deprivation. In less than 10 seconds, you would completely lose consciousness due to suffocation and burns. However, if you were standing on the dark side of Mercury, the situation would be completely different. Here, without the sun's scorching rays, the temperature plummets to a staggering -179 degrees Celsius. This extreme temperature difference creates a stark contrast to the searing environment of the sunlit side, a cold so profound that survival is impossible. Next, we turn to Venus. This environment is often described as the closest thing to hell. Venus has an exceptionally dense atmosphere, with a surface pressure 92 times that of Earth. This is equivalent to diving nearly a mile deep into the ocean on Earth. Even more terrifying, the air is filled with a toxic mixture of carbon dioxide and sulfuric acid clouds. The surface temperature reaches 467 degrees Celsius, hot enough to melt lead and zinc. Paradoxically, although Venus is farther from the sun than Mercury, it is even hotter. Standing on Venus, the first things you would face are the lethal heat and immense pressure. Sunlight filters through the thick clouds, casting an eerie orange glow. You might see a barren, rocky landscape, but you would quickly be swallowed by the thick haze. The air is filled with carbon dioxide and nitrogen, with absolutely no oxygen, and is incredibly toxic. The moment you land, you would encounter unprecedented torture. The immense pressure would instantly crush your body, as if you were being squeezed by a deep-sea submarine. The air in your lungs and sinuses would be forcibly compressed. Your skin would rapidly scorch under the extreme heat, your moisture would evaporate, and your organs would begin to fail. More terrifyingly, the air on Venus contains droplets of sulfuric acid. But strangely, you wouldn't be drenched by acid rain, because these acid droplets would evaporate before they reach you, a phenomenon known as virga. However, this would bring you no comfort. The surrounding temperature is unbearably high. Metals would glow a dim red in this heat. Your helmet's visor would quickly soften and melt. Any exposed skin would be rapidly carbonized. You would be pressed down, unable to move, your knees buckling, your body compressed, and your bones breaking under the heavy pressure. It would feel as if an elephant were pressing down on every inch of your body. The toxic substances in the air would burn your lungs from the inside. In less than a second, you would lose consciousness from lack of oxygen. If your body miraculously remained intact, it would be dissolved and incinerated in Venus's high temperature, high pressure, and acidic environment. The Venusian environment would completely destroy all traces of human existence. Flying past Earth, this blue oasis, we arrive at Mars. This red planet, though seemingly more inviting than Venus, holds a silent and deadly end for any unprotected human. The atmosphere of Mars is extremely thin, only 1% that of Earth's, composed mainly of carbon dioxide, making it nearly a vacuum. There is almost no oxygen to breathe. The astonishingly low atmospheric pressure would cause liquid water to boil and evaporate instantly. The temperature is also extremely cold, averaging around -60 degrees Celsius. It might rise to 20 degrees Celsius at noon during the day, but at night, the temperature plummets to -140 degrees Celsius. If you stood on the red sands of Mars without a spacesuit, your first reaction would be to the hazy, reddish-pink color of the sky. The distant horizon is covered by a layer of red dust. Due to the thin air, although Mars has wind, you would hear no sound of it at all. But it wouldn't be long before the real crisis arrives. You wouldn't be able to take a single breath. When you open your mouth to try to breathe, you would inhale nothing because the atmospheric pressure is so low. The moisture on your tongue and in your lungs would begin to boil rapidly. You'd hear a cold but painless hissing sound coming from inside your body. Your skin would feel tight. While you wouldn't immediately explode, the liquids in your blood would start to form gas bubbles. In less than 10 seconds, symptoms of oxygen deprivation would quickly appear. You would then have only about 15 to 20 seconds of consciousness. At the same time, your body would start to lose heat. The Martian air is too thin to conduct heat effectively, but the rapid evaporation of moisture from your eyes and lungs would create a strong cooling effect. Exposed skin would quickly feel the invasion of extreme cold. Your vision would start to blur and darken as your brain is deprived of oxygen. You might feel a slight tingling sensation, the feeling of blood vessels rupturing under the pressure difference. Or you might taste a hint of rust in your mouth, a taste brought by ruptured capillaries. After about 30 seconds, you would lose consciousness due to severe hypoxia. A few seconds later, you would die silently. The low pressure and extreme cold of Mars would cause your body to undergo sublimation. Your blood would boil, and your body temperature would plummet. The frozen desert of Mars would mummify your remains, preserving them completely. The end on Mars is one of suffocation and boiling bodily fluids. However, compared to being burned alive, such a death could almost be called peaceful. Perhaps in ancient times, Mars once harbored life, but now, for anyone unprepared, it is just a deadly wasteland where even the simplest act of breathing brings unbearable torment. Now, let's venture into the outer solar system. You might ask, what is it like to land on a gas giant? Falling into Jupiter is like falling into a planetary abyss. Jupiter has no solid surface. From space, its surface is merely the top of cascading cloud layers. Entering Jupiter's atmosphere, you would instantly plunge into a world of violent storms and extreme pressure. At first, Jupiter's upper atmosphere might seem gentle. Bands of orange, white, and red drift slowly beneath you. In the dim sunlight, you might experience a brief moment of freefall. However, the good times wouldn't last. Jupiter's gravity is more than 2.5 times that of Earth's, and it would pull you down at an ever-increasing speed. You would start to feel the change in the surrounding air, which gradually fills with hydrogen and helium. Next, you would encounter unimaginable winds. Jet streams with speeds of 644 kilometers per hour sweep through the cloud layers. The violent winds would toss you in all directions. Huge and complex storm systems would surround you, storms large enough to swallow Earth, looming in the thick atmosphere. Perhaps you would be falling straight towards Jupiter's Great Red Spot, a superstorm that has raged for centuries, circling the planet's core. In this dim environment, lightning would suddenly tear across the sky. Jupiter's lightning is 3 times more powerful than Earth's. For a brief moment, it would illuminate the dark, cloudy sky, while the thunder is drowned out by the deafening roar of the strong winds and intense turbulence. You continue to fall, and the pressure increases relentlessly. About 48 kilometers deep, the pressure is already several times that of Earth's. As you go deeper, the pressure will increase to tens of times Earth's pressure, and the temperature will also begin to rise sharply, from -101 degrees Celsius in the upper clouds to temperatures far exceeding the boiling point. As you fall, your body, under the dual assault of pressure and heat, would feel an unbearable weight. The air would become as thick as water. You would no longer be like a skydiver, but like a deep-sea diver. At 10 to 20 atmospheres of pressure, your body would begin to be compressed. Your lungs would collapse, and cavities like your sinuses and inner ears would rupture due to the immense pressure. As the gas becomes denser, your body would be compressed even more. Eventually, everything would descend into darkness. Sunlight cannot penetrate this deep. The only light would come from occasional flashes of lightning and the faint glow of distant electrical discharges. Your bones would begin to break under hundreds of atmospheres of pressure. The immense power of the storms would continuously tear at your body. Ultimately, the combination of pressure, heat, and mechanical stress would vaporize you. Your molecules would long have been integrated into Jupiter's vast atmosphere. You would disappear long before you could touch any surface. Imagine, even robots struggle to survive on Jupiter. How could a human? The Galileo probe once entered Jupiter's atmosphere, but was quickly destroyed by the extreme pressure and heat there. For humans, there is no other fate than to be completely disintegrated in the belly of the solar system's largest planet. Our journey continues to Jupiter's younger brother, Saturn. As you approach Saturn, you can't help but be captivated by its magnificent rings. Countless ice particles glisten in the sunlight, forming a wide-band structure around the planet. The sight is breathtaking, but beneath this beautiful exterior lies a deadly danger. Saturn is far from the Sun. Entering this planet, you would find it to be an extremely cold world. The temperature at the cloud tops is as low as minus 178 degrees Celsius. If you entered Saturn's atmosphere, your fate would be similar to that on Jupiter, eventually being crushed by the cold, dense hydrogen and helium haze. However, the space around Saturn is just as unforgiving, almost as deadly as the planet itself. Saturn's rings are composed of water ice fragments, ranging from tiny particles to rocks several meters large. These fragments orbit the planet at speeds of tens of thousands of kilometers per hour. For an unprotected you, this is like facing a storm of high-speed bullets and cannonballs. The ice and rocks in the rings glisten as they streak through the air. Initially, the smallest ice particles would hit your spacesuit like searing snowflakes. Then, larger, pebble-sized fragments would impact with explosive force, instantly piercing your body. More fragments would follow, ice and rocks raining down on you like a storm. Fist-sized chunks could tear off your limbs, while massive boulders could blow you to pieces. Within seconds, your body would be riddled with holes. Your blood, exposed to space, would simultaneously boil and freeze, scattering among the rings, instantly becoming sparkling, deep red ice crystals. Everything would happen in an eerie silence, as sound cannot travel in a vacuum. The remnants of your body would continue to orbit with the ice in Saturn's rings, eventually becoming a part of them, forever lost in this cold, unforgiving space. The seventh planet, Uranus, is often called an ice giant, and it lives up to its name. It has the coldest atmosphere in the solar system, with temperatures dropping to 49 Kelvin, almost absolute zero. Here, an unprotected human would be almost instantly frozen solid. There is no oxygen in Uranus's atmosphere. It is mainly composed of hydrogen and helium, with trace amounts of methane, which gives the planet its blue-green hue. Moreover, the clouds of Uranus may also contain ammonia and hydrogen sulfide, which are extremely toxic gases. Although the pressure at the cloud tops of Uranus is not as deadly as that on Jupiter or Saturn, it will eventually exceed Earth's as you go deeper. However, these pressure issues are irrelevant to you, because you would have died long before. The biggest killers on Uranus are the extreme cold, toxic gases, and violent winds. Yes, Uranus has weather. The wind speeds in some areas can even reach 900 kilometers per hour. Imagine what that would be like, a frozen hurricane made of toxic gas. As you enter Uranus's upper atmosphere, the sunlight is almost invisible. The sun is just a distant point of light. You are enveloped in a pale blue glow. The temperature drops rapidly. The moisture in your eyes, nose, and mouth would immediately begin to freeze. A thin layer of frost would quickly form on the inside of your helmet's visor. Inhaling a single breath of the planet's air would be almost instantly fatal. Your body would begin to convulse from lack of oxygen and poisoning. Within seconds, you would lose consciousness. If you miraculously held on for a moment, the bone-chilling cold would rapidly penetrate your body, bringing unbearable pain. In less than a minute, you would be dead. Your body would continue to fall until the increasing pressure crushes you into countless icy fragments. The extreme environment of Uranus would swallow you in an instant, leaving no trace. Imagine your body is revived, ready for another descent. This time, we arrive at the edge of the solar system, Neptune. This beautiful blue giant has the most violent weather in the solar system. The atmosphere is extremely cold, with temperatures only slightly higher than Uranus's. The cloud top temperature is about 55 Kelvin. Wind speeds can reach up to 2,100 kilometers per hour, making them the fastest sustained winds in the solar system. For any unprotected human, this place brings a swift, brutal, and disorienting death. Far from the sun, there is almost no light. The entire world is shrouded in an eternal, dim glow, near total darkness. As you enter Neptune's upper atmosphere, you might catch a glimpse of some massive storm systems, like the Great Dark Spot once observed by Voyager 2. The moment you enter, you are swallowed by a terrifying storm. The thin upper air quickly becomes dense. Supersonic storms hit you with full force. The wind speed exceeds the speed of sound. The air itself becomes a sandblasting weapon. Tiny frozen methane particles become sharp shrapnel, tearing everything apart. You are like a rag doll, thrown about by the storm's power, losing all sense of direction in a relentless spin, completely unable to control yourself. The cold mercilessly pierces your skin, but the trauma from the wind may be more terrifying than the cold. In Neptune's upper atmosphere, although the pressure isn't immediately fatal and you might last a few seconds longer than on Jupiter, the brutal environment would quickly end everything. After a few seconds, any protection would be destroyed. Exposed skin would be subjected to the supersonic, icy air. Your skin would be torn, your flesh scraped to the bone by frozen methane crystals. Ultimately, your remains would be disintegrated in Neptune's endless storms, completely disappearing into this barren land. After a long journey through the solar system and experiencing countless deadly environments, we finally return to the only place that welcomes us, Earth. Compared to the deadly and extreme environments of other planets, Earth suddenly seems like a gentle haven. Yes, Earth is the perfect habitat for human life. Its atmosphere provides the optimal pressure, a perfect mix of oxygen and nitrogen, and suitable temperatures and climates. We have liquid water that doesn't instantly boil away. The ozone layer protects us from the sun's harmful radiation. The temperature, most of the time, is within a range that humans can tolerate. Standing on the surface of the Earth, bathed in the warm sunlight under a blue sky, you can take a deep breath and enjoy every moment of peace and tranquility. It is worth noting that on every planet we visited in this thought experiment, death was almost instantaneous. On Earth, however, life not only survives but thrives. This contrast is so stunning and humbling.